Alright, ladies and gentlemen, we are on our last Newton's Law video, Newton's third law of motion. That law is called action reaction. And one thing I need you to focus on when we're dealing with action reaction is we're focusing on what I call a snapshot reaction, the moment when two objects make immediate contact. We're going to look at this video clip. You don't have to write anything down, but it's called a Rube Goldberg, and it is a wonderful way to see many different action reactions. Just watch. It's not going to be the whole thing. If you notice, every time something moves, it starts off a chain reaction. Every moment of contact is action reaction. Alright, so Newton's third law, this is going to be the definition. For every action, there is an equal and opposite, that's a really long blank for this, sorry, opposite reaction. That's the only word that goes there. An action-reaction pair is a set of forces that are always equal and opposite. So earlier I just said that you needed to focus on that snapshot moment. So if you could take a picture at the moment that this person's hands make contact with this wall, that's the action-reaction pair. It is just a snapshot. Okay? We know in reality that if this was a brick wall, that this person does not have enough force, unless they're Superman or the Hulk, to knock over this brick wall by themselves. We know that when you push in against something, something pushes back on you. So if you take your hand and you push down on the table with your fingertips, you shouldn't feel pressure. Okay? I'm pushing down. The table is pushing up against my fingertips. That's the pressure that I feel. Okay, so the action is me pushing down. The reaction is the table pushing up against my fingertips. Alright, our reaction force on box 3 is always in the opposite direction of our action force. So the directions are going to be opposite. And the reaction force, the reaction force is always equal to the action force. What that means is this. If I have forces acting on something, for example, this box, and let's say I push against this box, the moment that the force that's pushing against the box makes contact with the box, the moment these two actually touch, if I could take a picture at that moment, the amount of force being applied according to Newton's law states that the forces are the same amount. So we could say the force to push is 4 newtons. The force the box is pushing against the hand or whatever object that's touching it is also pushing 4 newtons back. So the box is pushing 4 newtons to the left, and then the hand or the object is pushing 4 newtons to the right. At that snapshot moment, those forces are equal, but they're moving in opposite directions. So the action force would be 4 newtons pushing to the right, and the reaction would be 4 newtons pushing to the left. Action reaction has to come in pairs. Alright, let's look at another example. The moment that these two people make contact, they're pushing the same amount of force against each other. If I could take a photo at the exact moment that their hands make contact. So, person A is the action force. Person B is the reaction force. Okay. Person A is pushing against person B, who's also pushing in the opposite direction. Person A is pushing to the right. Person B is pushing to the left. Okay? But the moment their hands make contact, their forces are exactly the same. So person A is pushing 10 newtons. Person B is also pushing 2 newtons. At that exact moment, logically, we do know and understand that one of them might overpower the other. But just at that moment of contact, their forces are equal and opposite. Here's another example to look at. A balloon that is being deflated. Okay? As everything is released from this moment, okay, the moment of contact, when you release the balloon to let the air out, the balloon is going to move this way. That's your action. Or it could be your reaction, however you read it. And then your reaction is going to be your air moving out. Okay? The forces amount are the same at the moment of contact, right here. But their directions are going to be opposite. But you know eventually the forces are going to level themselves out to the correct amount. Alright, here's your final box. The mass affects the acceleration or the change in motion, even though the action-reaction pair is equal. But remember, when we're talking about third law, we're talking about that snapshot moment, the moment two objects make immediate contact. If I could take a picture at that exact moment. Now, all three laws you can kind of tie in together. So this law ties in Newton's second law very well. So that next section says that according to Newton's second law, acceleration is affected by force and mass. But the third law tells us that the forces are equal and opposite. Okay? So remember, third law is a snapshot. It's the moment two objects make contact. But then we know ultimately that some objects apply greater force than others, and some objects' masses may overpower a certain amount of force. Okay? So we have to remember that our forces are equal at the snapshot moment, but the acceleration is different because of the differences in mass. So when we're talking about action-reaction, they're going to mention pairs that are equal and opposite with the same amount of force. But when we're talking about Newton's second law, we're talking about how unbalanced forces affect that object's acceleration. And guys, that's pretty much it. Make sure you have all your notes and just be ready to do some practice.